In this video, we're going to derive the first quadrant of the unit circle. So just a refresher, when we talk about the unit circle, we have a circle with radius 1, i.e. 1 represents a unit. And so that is why it's called the unit circle. Now, when I say I'm going to derive the first quadrant, recall that in your xy plane, we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In this video, I'm going to derive the first quadrant, and then after that, we're going to look at how to use the first quadrant to derive the entire unit circle. So let's first dive into the first quadrant. Okay, so now if we recall what a radius is a measure or a line that measures from the center to the edge of your circle. Now, if we're in the coordinate plane and we are saying that this is a unit circle, then this radius will have a measure of 1 unit. And so this point, if we're on the x-axis, well, this point is going to be 1, 0. Likewise, if we were to go at the top, this point, the intersection of the unit circle and the y-axis, well, that's going to be 0, 1. Okay? Now, there are 3 different angles inside the quadrant that we're going to look at. First, let's look at the 30-degree angle. So, for instance, let's say I draw a 30-degree triangle, right triangle to be more specific. Again, observe or notice that here we are going from the center of the circle to the edge of the circle. So our radius here is 1 unit. Now, let's say I draw another, so let's recall here, this is 30 degrees. And before I go to the next part of this, if we have a 30-degree angle here, and this is a right triangle, which is 90 degrees, then we can calculate the last angle of the triangle. We can do this since we know that all angles in a triangle add up to 180 degrees. So we would do 180 minus 90 plus 30. Some of us can already look at it and tell, but for the rest of us who can't, this would be 180 minus 120. So this would be 60 degrees for our last angle. This is what we call a 30, 60, 90 degree triangle. Now, recall our aim here is to figure out, well, what is this intersection between this radius and the unit circle? Now, in math, we like to do things to make life a little bit easier. Now, let's say we draw another 30-degree angle here. And I'm going to pretend, okay, maybe not there. Let's try again. Okay. Alrighty, so let's say we draw another 30-degree angle. And we're going to assume that it's exactly 30 degrees. Alrighty, so this is going to be 30 here. So this will make the last angle here also 60 degrees, right? And this will be a 90-degree triangle on the inside. So I'm going to pull this triangle out. I like to pull them out so that we can see clearly what's going on. So if I come out here, this is the triangle I have. Now notice that here we have 30 plus 30. So the big triangle, let's say I were to use the green, This is the triangle I just pulled out. So this big angle here is going to be the angle corresponding to the angle here. And so that's actually going to be a 60-degree angle. That makes this angle also 60, right? Because that's what's here. And then our angle here will also be 60 degrees. Now, if any of us recall this triangle with all angles equal, that's what we call an equilateral triangle. And if the angles are equal, so are the sides. But we can also prove this since this is also the radius from the edge of the circle, or from the center of the circle rather, to the edge. That's going to be also 1. And then the fact that this is a equilateral triangle, the base is also 1. Now, the purpose of this is because this base is going to help us to determine this length here. Let's use another color. Let's say we use the red. Now, remember, the original triangle we had was this. I'm using the red so we can kind of see what we are doing here. And if we are able to identify, well, what is the x, right? The x value is what we're looking for. The x here, or the length of the x there. And then we're also looking for the length of the y here, right? That will give us our coordinate point here. We can label it x and y. So this is our x, and this would be our y. So if you notice, half of this base, we called it the base. Half of this base is corresponding to our y here inside the triangle. Now we can determine what that piece is, the half of the base here, by the simple fact that this entire line is 1. And so if we want to know what this is measuring, it's going to be half of 1, or just 1 divided by 2, which is actually just 1/2. So the y here is going to be 1/2. Now that we have y, we can utilize something from our toolbox, right? If you recall, you've probably heard of the Pythagorean theorem. And that states, so Pythagorean, and that's just short for theorem. Okay, so if we're looking for the Pythagorean theorem, this tells us that a squared plus b squared is equal to c squared. And in this instance, a and b are the legs of my right triangle, and c is going to be my hypotenuse. So if we were to compare what we have here, we see that for this triangle, or 30-60 triangle, this is my x, right? And that's my y. The x and y are acting as my legs. So that means x squared plus y squared is equal to my hypotenuse is going to be my radius, which is 1. Or you could say 1 squared, right? Which is 1. But we don't know what x squared is, or we don't know what x is, but we know what y is, which is 1/2. So we can plug that in. And we know that 1 squared is 1. So if we are to solve now, we can figure out what x is. So here we have x squared plus, so when we square a fraction, we're going to square the numerator and the denominator. Okay, so 1 squared is 1, and then 2 squared is 4. and that's going to be equal to 1. Now we can simplify, so we will subtract 1/4 from both sides. And so we have that x squared is going to be equal to 1 minus 1/4. Now, of course, we need to have like denominators when we multiply. We can put this 1 over 1, and we need to figure out what is the LCD. Well, the LCD between 1 and 4 is 4, and so I need to have a 4 in the denominator. So I should think to myself, what times 1 gives me 4? Well, that's going to be 4. So that would be 4 at the bottom times 1. But whatever I do to the bottom of a fraction, if I'm wanting to have an equivalence fraction, I must also do to the top. So I'm going to put a 4 here as well. Okay, so now if I were to continue in simplifying this, I would have that x squared is equal to 4 divided by 4 minus 1/4. What this gives me, now I can just subtract across. It's going to give me 3/4. Okay, but that's x squared. So x squared is 3/4. So now we need to figure out, well, what is the value, right? What is the value of x? That's why we're here. We're here to find the value of x. So we can now take the square root of both sides, right? So this would cancel my square here. So I would have x is equal to, alrighty. So now when you're taking the square root of a fraction, that's equivalent to the square root of the numerator divided by the square root of the denominator. Now, 3 is not a perfect root, so that will just stay under the square root. However, we can take the square root of 4, and that will give us 2. We're going to take the principal root. So what this means for us is, when I say principal root, we're going to take the positive value. So now what does this mean for us? This means we now have a value for x. So we can come back to our triangle here, and we can plug in. So x is root 3 over 2. Okay, now that's the first coordinate for your 30-degree angle. Now, instead of going straight to, so the 3 angles that we mentioned that were important were your 30 degrees, your 45 degrees, and your 60-degree angle. However, since it's easier to do your 60-degree angle next, that's what I'm going to do. And you'll see why. Now, if I were to draw, let's just kind of look at it. Hopefully, my colors are standing out. Now, if I were to draw a 60-degree angle, okay, so that's going to be the purple here. I still have my right triangle. But notice what happens if this is 60 degrees. So the purple angle is 60 degrees. Well, that means that this is going to be 30. So if you can observe, this is the same triangle we just worked with, right? But now the y is on the longer side and x is on the shorter side. So all we're going to do is switch my x and my y's from what I had for my 30, 60, 90-degree triangle before. In other words, here my x value was the longer side, and that was root 3 over 2, but now that's my y. So y is now root 3 over 2. And x is now 1/2, because that's my shorter side of my triangle. And we're done with the 60-degree angle. Now, we will have to now fill in our 45-degree angle. Okay? So here we are. I'm just going to redraw our circle here. Still in the first quadrant. But this time I'm going to draw a 45-degree angle. Triangle. Right triangle. So this is 45 degrees. Now, a similar way how we were able to identify the other angle, here we can identify the last angle in this triangle by doing the same thing. If you do 180 minus, so we know that this angle is 90 plus 45. So this is going to be 180 minus 135. And that's going to give us 45. Or if you could have observed, it's a 45, 45, 90. Now also recall that, again, we have our radius that's going from the center of the circle to the edge of the circle. So this is going to be 1. Okay. Now, I don't know if you guys recall, but this is a what? A triangle that has two sides that are equal. So it's an isosceles triangle. Now, if you have two angles equal, that means the sides, the corresponding sides must be equal. Now, this is still going to be representing my x, right? This distance here would be x. This distance would be y. Okay, now, since this is my x and this is my y, of course, I'm trying to figure out this coordinate or what the intersection of this 45-degree angle is with my unit circle. I can use, again, my Pythagorean theorem that states that a squared plus b squared is equal to c squared. Now, notice here that we're saying that these two things are equal. So in other words, we know that x is equal to y or vice versa. Or y is equal to x. My legs are still x and y. So that means that x squared plus y squared is equal to c squared. But if we're saying that x is equal to y, I can actually plug in this step here. In other words, I can write x squared plus x squared, right? If x is equal to y, I can just plug in for y. It's going to be equal to c squared. Well, if you add these two, that means you have 2 times x squared is equal. Well, we know what c is, so I can plug that in. Is equal to 1 squared. So now, let's say we want to continue solving now for x. Well, we can simplify this part here. This would be 2 because we know what 1 squared is. So 2 times x squared is equal to 1. We can divide both sides by 2. So x squared is equal to 1/2. But recall, we're looking for what? We're looking for x. So we can do what we did before and take the square root of both sides. So the x and the square root cancel. So that means x is equal to, recall the trick we did earlier, the square root of 1 divided by the square root of 2. Now, x is equal to square root of 1, that's 1, divided by the square root of 2. If only, in math, we do not like to have a square root in the denominator. For us, it's not simplified. And so we have to simplify it if we get something where we have a square root in the denominator. And so when I say simplify it, we're gonna, we can say rationalize. We're gonna rationalize it. And that means we're gonna multiply by the square root of 2 over the square root of 2. And if you think about it, you're really just multiplying by 1 because anything divided by itself is just 1. Now, the purpose of this is because once I'm done, the square root in the denominator will go away. So if we multiply 1 times root 2, that's going to give us root 2. And then the square root of 2 times the square root of 2 is 2. So x is the square root of 2 over 2. Now let's go back up here. We just said that x is the square root of 2 divided by 2. But we also said that x is equal to y. So that means y is also the square root of 2 divided by 2. So now we know the coordinate for our x and y, the intersection between the unit circle and our 45-degree angle. So that's going to be the square root of 2 divided by 2. And again, the square root of 2 divided by 2. And that is their first quadrant. So let's put it all together. The first quadrant of the unit circle. So the first quadrant, let me draw our circle again, and then we're just going to fill it in. Alrighty. So we establish this point is going to be 1, 0. If we were to draw our 30-degree angle, okay, my x here is going to be root 3 divided by 2, and my y is 1/2. My 45-degree angle is going to be in the middle, and we just established that that is going to be root 2 over 2, root 2 over 2. And then my 60-degree angle, we just flip our 30-degree angle, and that's going to be 1/2 root 2, root 3 over 2. All right, so this is 30 degrees, 45, and 60. And then here we have 0, 1. Okay. Now, the last thing that we want to put in, of course, you have your degrees. This would be 0 degrees here because that's where you're starting. And then, of course, this is my right angle. So at the top here, we would have 90 degrees. Now, the last thing that we would need to do is to convert our degrees to radian measure. And so if you want to go from degrees to radian, you're going to multiply by pi over 180. Okay, so whatever your degrees is, you multiply that by pi over 180 and you'll get radian measure. So let's do that for our 30-degree angle. So we have 30 times pi divided by 180. Okay, well, we see that these two things are divisible by 10. It means you can cancel the zeros. Okay, or it means that 10 divides 30 3 times, and 10 divides 180 18 times. And then if I look at this, I see that 3 divides itself once, and 3 divides 18 6 times. And so this gives me pi over 6. So my radian measure for a 30-degree angle is pi over 6. Now, what about for 45 degrees? We're doing the same thing. 45 degrees times pi over 180. Okay, now you can actually use a calculator here, but if you think about it, 180 is 2 times 90, and 45 times 2 is 90. So 45 can divide evenly into 180 4 times. So this becomes pi over 4. So for my 45-degree angle, that's going to be pi over 4 radians. Now for the 60-degree angle, that's going to 60 times pi over 180. Again, I noticed that I have zeros here, so I can use 10. Get cancels my zeros. And then I know 6 divides itself once. 6 divides 18 3 times. So this becomes pi over 3. Okay, I can put that in for my radian measure. Then the last one, 90 degrees. So that would be 90 times pi over 180. Right? And so here we can see that 90 goes out evenly, or you could just use the zeros first, right? If we use the zeros first, let's use the zeros first. So if we use the zeros first, or we use 10, the zeros go away, and then you see 9 divides itself once, 9 divides 18 2 times. So this gives us pi over 2. Alrighty? Okay, so this is going to be pi over 2. And that is the first quadrant of the unit circle. Now, if you know the first quadrant of the unit circle, you can easily come up with the other 3. Stay tuned.